Section 9.3 is on circles. The definition of a circle is the set of all points in a plane that are equidistant from a given point, which is the center. The segment from the center to any point on the circle is the radius. And the standard form of the equation of the circle is the quantity x minus h squared plus the quantity y minus k squared is equal to r squared, where the center is the point hk and the radius is r. And this should look familiar from geometry. I think we did it back in chapter 8 or 10, chapter 10. Okay, here's a little couple little images from your textbook. So here's a picture of a circle. You should be familiar with what that is. There's the center. The radius is this segment that goes from HK, and XY is actually any point on the circle. Standard form, if your center is at 0, it's just x squared plus y squared equals r squared. But if your center is hk and the radius is r, it's quantity x minus h squared plus the quantity y minus k squared equals r squared. So let's take a look at several examples here. Write an equation for the circle that has a center at -7, -3, and has a radius of 13 units. So for this one, I'm going to go ahead and write the formula out so you're familiar with it. You probably should memorize this. It's not too difficult. Okay, so since my center is -7, -3, my h is -7, my k is -3, and my radius is 13. So I just plug those numbers in here. So x minus a -7 is x plus 7 squared, plus y minus a -3 squared is y plus 3 squared, equals r squared. 13 squared is 169. And that's the equation. Oops, I forgot the squared. There we go. So this one says write an equation for the circle graphed below. So remember, the three key points of information we need are the coordinates of the center and the radius. So looking at this, it looks like my center is at the point 4, 3. So that means that h is going to be 4 and k is going to be 3. And I can draw an infinite number of radii, but let's draw one that lines up with the lines on the graph. So this right here would be the radius, and the length of that radius is 4 units. So my r is going to be equal to 4. So now let's just plug those into the formula. So x minus 4 squared plus y minus 3 squared equals 4 squared, or 16. And that's the equation of that circle. This one gets a little more difficult. It says write an equation for the circle whose endpoints of its diameter are -6, 4, and 4, 8. So in other words, what does that mean? I'll do a little sketch here. So I have a circle here, and it has a diameter, and the endpoints of the diameter are 4, 8, and -6, 4. So what I need to know is I need to know what are the coordinates of the center and what is the length of this radius. So I need to know my hk and I need to know my r. So here we're going to go back to the first section in this chapter, and we have to use distance and midpoint. So the midpoint of that diameter is going to give me my center. So remember, midpoint was x1 plus x2 over 2, comma y1 plus y2 over 2, where x1, y1 and x2, y2 are the endpoints of the segment. So I'm going to use -6 plus 4 over 2 and 4 plus 8, over 2, which gives me -2 over 2, or -1, and 12 over 2, or 6. So that's my center. So h is equal to -1 and k is equal to 6. Now to find the length of the radius, I'm going to want the length of half of the diameter. So the radius is actually going to be half of the diameter. And so to find the diameter, I'm going to use the distance formula. So the diameter equals the square root of, and it doesn't matter the order you'd go in, Let's do negative 6 plus 4 squared plus, oh, I'm sorry, no. Try that again. X2 minus x1. I'll go backwards. So 4 minus a negative 6 squared plus 8 minus 4. And I need the square root of that. So that's going to give me the square root of 10 squared is 100 plus 4 squared is 16, or the square root of 116. And I'm going to try to keep this exact as I can. So doing a factor tree on that and simplifying that, that gives me that that is equal to 2 times the square root of 29. Square root of 116 is 2 times the square root of 69. Now, that's my diameter, so my radius is going to be half of that, half of 2 times the square root of 29, or just the square root of 29. Now I have enough information to write my formula. So I'll have x minus my h minus negative 1, whoops, squared plus y minus k, which is 6 squared, equals r squared. The square root of 29 squared is just 29. So there's my equation. Okay. This example says find the center and the radius of each circle and then graph. Okay, so looking at the equation here, so I have x minus 3, the quantity squared, plus the quantity y plus 4 squared equals 25. So my h is 3, my k is a negative 4, and r is going to be, since 25 is r squared, r is going to be 5. So my center is the point 3, negative 4, and my radius is equal to 5. So to graph that, I'll graph the point 3, negative 4. There's my center. And now my radius is 5. So I'm going to go 5 units in each direction. So 5 units up, 5 units to the right, 5 units down, and 5 units to the left. That gives me a radius of 5. And then I'm going to try to connect to those, and try to make it look kind of like a circle. That's not too bad. Okay, that's how you do that one. Next example, same thing. State the radius and the diameter, but this one is not written in my standard form. I have to actually do that. So again, as we saw with the parabolas, this is going to involve some completing of the square. So I'm going to rewrite it so that I have my x terms together and my y terms together. So 2x squared minus 4x plus 2y squared plus 8y equals 32. So I need to complete the square with my x's, and I need to complete the square with my y's. So the first thing I'm going to do is pull a 2 out of there. So that's going to leave me with x squared minus 2x. Close the parentheses. I'll complete the square in the next step. Take a 2 out of this. Remember, I don't want a coefficient of my squared variable. And that's going to leave me with 4y something equals 32. Now let's complete the square. So my b is negative 2. Half of that is negative 1. Squaring that gives me a 1. So I'm going to add 1 here. But I didn't really just add 1. I really added 1 times this 2 over here. So since I added 2 on this side, I'm going to go ahead and add 2 on this side. Then here, to complete the square with the y's, my b is 4. Half of that is oh, I see what I did. I did something a little different in my notes. Anyway, I'm sorry, I'll keep going. This should work out. Sorry about that. B is 4. Half of that squared. Half of that is 2. That's going to give me a 4, so I'm going to add 4 here. But I didn't really add 4, I really added 8. So let's go ahead and add another 8 over here. So let's go ahead and factor this. So 2 times x squared minus 2x plus 1. Plus 2 times y squared plus 4y plus plus 4 equals, that's going to give me 42. And I see the problem here. I really don't want those 2's to be there, so I'm going to divide everything by 2. Divide that by 2, divide that by 2, and divide that by 2. And what threw me off was when my original notes, I originally divided everything by 2. So that's going to give me x squared minus 2x plus 1 plus y squared plus 4y plus 4. Oh, in case you're confused here, so I'm only canceling like these 2's here. And that's going to turn into a 21. That 2 in the denominator does not touch anything inside the parentheses. Okay, so this is a perfect square trinomial. It's going to factor into an x, the sign in front of b, which is negative, and then the square root of my c, which is 1 squared, plus, same thing here, a y. I have a positive in front of my b, and the square root of this c is 2 equals 21. Okay, so my center is going to be the point 1, negative 2, and my radius is the square root of 21, because remember in the formula 21 is r squared. So in order to graph, I can leave it square root of 21. I like that, but I don't know what that means to graph it. So that's approximately 4.6, but leave 21 in your formula. Okay, so let's graph that. Center at 1, negative 2, and actually let's say about 4.5. So I'll go 4.5 in each direction. 2, 4.5, and then 2, 4.5, and 2, 4.5, and go ahead and sketch that circle. Okay, that's not a wonderful circle, but you get the idea. So in this section we took a look at circles, something that we touched on in geometry, and we figured out how to find the radius, the center, how to graph, a fun problem if you're given the endpoints of the diameter, how to write the equation, and how to take an equation from this general form and put it into standard form.